I'm Ben Sharma, and the topic of my presentation will be managed data lake. And I'll talk about it from an enterprise view. What are some of the requirements and how do you go about creating a data lake? We have a lot of experience in customer use cases where Hadoop projects start in a POC and then kind of graduate into a production environment. And then as it kind of happens, what are some of the requirements to kind of productionize or operationalize your use cases in a repeatable way in a data lake environment? So what is a data lake? So before we talk about a managed data lake, let's talk about a data lake. So in large enterprise environments, you see a lot of different data stores. You have the transactional databases, you have operational data stores, you have enterprise data warehouses. And those are fine for the type of data that they were handling, right? But with the advent of all the new type of data, which may be generated outside of the enterprise, not within the transactional systems in the enterprise, you need to think about a different way of handling that data where not all data may be structured data. You may be getting data from logs and other operational systems. You may be getting a variety of different formats, and they may be coming in files, they may be coming in streams, and they may be coming in from database extracts and things like that. So how do you kind of bring data from all those different platforms into one repository where it can support those different formats? And also the fact that we used to do an extensive data modeling exercise to onboard the data into a warehouse is not valid anymore, because we want to create an agile data platform. We want to be able to quickly onboard the data and provide that agility. So you may do layout standardization for some of the data sets, but you may want to keep most of your data in its raw format. And then also from a query perspective, it's not just a SQL type of interface to query the data. You want to be able to programmatically query the data using various algorithms that you're writing on top of the data using different polyglot languages. So basically what you're doing is creating one unified repository where you can correlate across data sets from different lines of businesses or different units and are able to generate the insights in a much more agile way. So that is how we think about a data lake. So now that's all great, but how do you create these platforms and what are some of the challenges? So before going into that, so let's look at an example of old versus new. So in a traditional enterprise environment, this is a BI focused example. So you would have source systems bringing in the data into a ETL tool, which may be doing an ELT type of process where it's extracting the data, it's loading it into a target platform, and it's doing transformations, and it's standardizing the data and creating the third normal form tables, let's say. And then based on that, you're creating the data marts, which you're then serving through your BI layer. So that used to be how we used to do things, right? So in the new architecture, what we're seeing is that you're bringing in all different types of data into a data lake environment where you're keeping the raw data as is for as long as you want, based on retention policies and things like that. And then for certain use cases that you know of today, you may be doing some layout standardization or transformations of that raw data into the derived or the transformed data. And at the same time, you want to enable that agility with discovery and exploratory and ad hoc kind of analytics on that data. So you want to set aside an area where you're doing, enabling your data scientists to kind of create sandboxes and be able to do that. So from the data lake, you are then serving the EDW, if you will, in that BI example, by doing the transformations, doing the heavy lifting in the data lake, and then pushing the data out into the EDW for the data marts that needs to be created for existing BI tools that work off of the EDW, because you don't want to rewrite all of that. And at the same time, new generation BI tools are starting to work natively on the data lake itself. So you don't have to move data from the data lake into the data warehouse to be able to query and visualize the data. So that's kind of an example, if you will. All right, so let's talk about some of the challenges in building the data lake. So we kind of categorize them into 3 pillars, if you will. So of course, as Vikram pointed out, there are a lot of different kind of approaches. There's a landscape slide that he showed you with all the different tools and different frameworks and things like that. So which frameworks do you choose to build the data lake and the complexity that's involved in that? And then once you figure that out, how do you now kind of create managed data pipelines and have managed ingestion and organize and store the data with the metadata so that it can be used by various consumers in an effective way. And of course, from a governance perspective, security, privacy, and compliance is important for various use cases, especially if you're bringing in sensitive data and you're sharing the data lake amongst multiple consumers. And then the third pillar is that how do you derive value out of the data lake, where you're enabling your business users and giving them measures of quality of the data, right? How good is the data? How many good records versus bad records? And that is one of the challenges we see in the data lake environment, because Hadoop essentially is schema-less on write, so you're not used to the same data integrity checks that you would have in a database environment. So especially if you're bringing in data from external environments, you may be getting a lot of junk data, and once you're bringing in that junk data and you're doing analytics, it's garbage in, garbage out. So how do you get a measure of quality of the data as the data is coming into the data lake before you actually make it consumable for your analytics use cases? And then how do you create a catalog and kind of make it self-service for the IT users so that they can go through an iterative kind of approach of doing some of the data curation and data preparation steps as a line of business user, so that they don't have to rely on IT, which kind of leads to a very long development cycle. And then once they're satisfied with those data prep steps, how do you make them, how do you operationalize them so that they're reusable, so that it happens on the data that comes in tomorrow and the data that comes in the day after, and so on and so forth. So in order to solve these challenges, we kind of focus on a reference architecture for the data lake, and I'll walk you through this a little bit. So on the left-hand side, you see all the source systems. So this could be your enterprise data sources, operational data stores, enterprise data warehouses, or operational systems that are generating logs, or you're kind of getting data from external third-party systems. So you need to source the data into the data lake. So you need to have a managed ingestion layer to be able to source the data. Once the data comes into the data lake, we think about it as different zones of data in the data lake. So you can think of like a transient landing zone of getting the data into the data lake that could be removed once the data is in the right place. So we have a raw data zone where the data stays in its original unaltered state for whatever retention period you need, right? And there you may have some sensitive data. So for the sensitive data, you may want to tokenize and mask the sensitive attributes so that as you make that data consumable, you are kind of complying to the data governance policies that you may have. And then from the raw data zone, you may be transforming the data and creating some refined data sets. So that we consider the refined data zone, which is where you may be doing some data quality checks and doing some cleansing, layout standardization, and creating some common data models that you could use for different subject areas for different domains. At the same time, you want to enable your data scientists and other business users to do ad hoc stuff and have this discovery sandbox area, where it's less governed, but at the same time, you can enable rapid iterations that they can do on the data. We also consider this trusted data zone, which is where your reference data or data that based on which you're actually making business decisions or reporting for compliance or regulatory reasons, you want to store that data in the trusted zone in a very locked down manner so that not anyone can modify that data. And then on the right-hand side, you have the data consumers, right? So those are the folks that are using the data out of the data lake, or out of the different zones in the data lake. So foundational to all of this is basically the managed ingestion layer and a set of capabilities that you need to think about as you build a data lake, which includes metadata management, which includes data quality. So you may have a rules-based engine, or you may create some algorithms to be able to define quality or generate quality automatically. A rich data catalog so that you know what is the inventory of your data lake, and then, of course, security and governance policies. So you need to think about a reference architecture like this as you think about building your data lake. So in order to kind of go about building the data lake, ingestion is one of the key aspects. I know Jay is going to talk quite a bit about streaming ingestion, but being able to handle all types of ingestion of data, whether it's files or streams or database extracts, being able to deal with change data, because you're not getting full dump of the data every time. You're getting incremental changes in the data from source system as you're bringing that in. So how do you deal with that? And especially in different industries, you have different requirements. So for example, in insurance, one use case is that you get a claim record that is pre-adjudicated, and then you go through an adjudication process, which means that record keeps changing based on the adjudication process over a period of time. But yet you want like the latest snapshot of that claim record, right? So you have to go through a process of being able to reconcile that record over a period of time and provide the latest snapshot. And also the other aspect here is that, going back to the point about metadata, is that you want to be able to capture operational metadata as you're ingesting the data, as new data arrives, as the data gets transformed from the format that it arrives in to the format that you're creating out of the ingested data. And you want to do this in a repeatable, managed way so that you're creating managed data pipelines. So when we talk about metadata, oftentimes you need to think about kind of the 360 view of metadata, which includes the technical metadata, which is kind of the format, the structure, the fields, and things that are captured about the data. But then there's also operational metadata. How much data came in for that particular entity? Where is it located? What is the quality of the data? What's the lineage? What's the provenance? So those are the operational metadata attributes. And then also business metadata, so that you are able to tie that into a standardized vocabulary across your enterprise with business names, descriptions, tags, and so on and so forth. So once you have the data coming in, you have captured the metadata, and you have a metadata framework in place. What we see is that you need to have a bottom-up approach of data preparation and iterative wrangling, if you will, like what Vikram was saying in Michelle Getz's kind of article that she refers to. And then also tie that with a top-down approach. So you may have enterprise-wide data governance rules where you need to capture lineage, where you need to enforce these security policies. So you need to have a hybrid approach of not kind of tying it down such that people who are data consumers cannot do their self-service data preparation steps, but at the same time be able to integrate that with an operational layer so that whatever they're doing in an ad hoc exploratory manner can be somehow promoted to become an operational workflow after a governance process. So let's say your data stewards or data architects can verify or can approve it so that it now becomes a part of your day-to-day transformations and the metadata is captured. And of course, security plays a big role. So a lot of these data lakes are shared platforms across the enterprise, which means that different business units, different groups have access to it. So you need to think about concepts of multi-tenancy on how you give access to what data based on access control lists and things like that. And also the data that is coming in, if it has sensitive attributes, being able to mask or tokenize the data as you're storing the data at rest. So oftentimes, again, going back to the metadata model, if you use entities or metadata kind of as a foundational layer, you could now define policies based on that metadata so that you can specify which groups or which users have access to what data for what period of time and so on and so forth. One other trend that we're seeing more and more in enterprise environments is that it's no longer that enterprises are just deploying on-prem data lake environments, right? So we see a lot of adoption of cloud infrastructures. So now you need to start thinking about how you provide a seamless kind of data management and data governance layers where some environments may be on-prem, some environments may be in hybrid cloud environments, and it could be different cloud environments, right? So now with all the regulations where countries in Europe need to keep the data in those countries, you may have different service providers providing the infrastructure so that you're creating an end-to-end logical data lake, if you will. So you need to think about visibility of the data and the governance on that data as you have elastic cloud environments or persistent cloud environments that augment your on-prem environments. So this is a use case from one of our customers in the telco space. So this is an operator that is trying to bring in data from their network assets, like the switches and routers and cell towers and cell sites, along with the customer data, like CRM and billing and inventory data from their BSS systems, into one data lake environment so that they can now have, say, customer usage or subscriber usage models that they can create. So at an individual subscriber level, they can see based on IPFix and SNMP and CDR data coming in from the network elements, what is the subscriber using? Being able to offer differentiated services to those subscribers in a near real-time basis, right? Based on policies and other things. So then also capacity planning and network utilization is another big use case because you want to see where the congestion is in a wireless network or in a wireline network and be able to push bandwidth to those congested data points because a lot of things are becoming software driven anyways with software-defined networks and NFV and things like that. So how do you now dynamically provision a bunch of network elements in software because you know that there is congestion in one area and you can relieve the congestion from that perspective. So those are some of the use cases that open up. At the same time, you can use the data lake to also kind of provide inputs to your existing legacy applications that are, say, still running on the data warehouse, but you're now able to limit the footprint of the data warehouse by doing most of the heavy lifting in the data lake and thereby kind of also storing the data for extended period of time so that you can do correlations and things like that in a much easier way. So when we think about an integrated data lake management platform, these are the different aspects that we consider. So managed ingestion, metadata management, data quality. I mean, that is often not talked about in a data lake environment, but we feel that that is very important as you build these polyglot persistence layers which don't have any schema validation when you write the data. Data lineage, as you kind of transform the data from one format to another, profiling, so that you can see what are the attributes of the data. Is there skew in the data that you need to be aware of as you kind of consider that data for your analytics use cases? And then other kind of operational things like data lake operations you want to see in a managed pipeline, what's going on in the data lake, and then inventory of the data as you bring in more data. So the whole idea here is to kind of create this managed data pipeline that goes from raw data that is coming in to the insights that you're generating out of the data. And in order to do that, think about kind of different functions of that managed data pipeline with ingest, with organize, where based on metadata, you're organizing the data in the formats that you want. So you may want to take some of the raw data and convert it into a columnar format. so that it's easier for your query engines to work on, and so on and so forth. And then enrichment, as you know, need exists for kind of creating new data models that you can use for your analytics and other use cases. And then oftentimes, whatever you're doing in the data lake needs to be extracted and provided to a downstream system. So you need to think about what your extraction mechanism would look like. I mean, a lot of the BI tools and other consumers are coming to the data lake, but oftentimes you also need to kind of populate downstream systems. So this is another use case for healthcare in the payer industry. So data coming in from various different sources, whether relational database systems or in a streaming manner, or files that are coming in from third-party providers and so on and so forth. The different data sets we see is claims data coming in from, say, the provider systems, EMR data, because a lot of data from Epic and Cerner and those systems could be brought in to create like a member or a patient 360 view, and then other types of data sets, right? So you need to think about change data capture and streaming collectors and file collectors to kind of bring the data into the data lake, so that on the right-hand side, you're kind of providing the data to the various consumers, and some of the use cases that we see in the payer space is HEDIS reporting for CMS compliance and bundle payments, as the whole way payment structure in the healthcare space is changing. So you don't pay for, on a per transaction basis, you pay for a given outcome. And then let's say if a physician's office and lab and pharmacy, they all collaborate and they break down that payment into what each one has done to provide that outcome. So if the outcome is better, then you get more money. If the outcome is not good, then you get less money. But that's kind of the whole idea of CMS, new reimbursement mechanisms. And then of course, readmission risk for hospitals at least. That's a big thing where they want to kind of take all this data and be able to predict which patients are going to be readmitted within 30 days so that they can actually prevent that, because otherwise they have to pay penalties, and which is a loss of revenue for them. And then some of the other use cases. So that's kind of, in a nutshell, what I wanted to talk about, give you an idea of what are some of the requirements for creating a managed and a governed data lake, and some of the use cases that these data lake environments can enable. All right, thank you.